Yeah, just for introduction. So you are online for the country. You are show your presentation on YouTube. There are some other guys watching, and maybe we can ask you some questions by chat. So Luis will. Yeah.
Yes, I'm sorry, I don't speak Portuguese. Only English.
So here now we have mainly the guys involved in hydrology, researchers and development guys. So the operational guys that support research in the situation room, and also researchers like Conrado, is expert in hydrology, that's a part of what we're doing here is part of our regular program for seminars. So each 2 weeks we have someone giving talks and presentation for us. So I would like to thank you for this time that you're spending here. And well, after your presentation, we can talk later about other topics. Okay. So I have to go to the other. Okay. Then I'll come back to this. Thank you very much.
Thank you.
So I don't know if you would like to.
Yes, you can all present themselves. Also, I want to introduce my colleague Emmanuel. He's from Nodinet. And actually, we are here in Brazil because we just finished a project with the FCTH in Sao Paulo. We prepared some slides at the end of the presentation to inform you to talk about this project. So, Emmanuel, if you want to say a few words.
Yeah, just to thank you for my visit.
Yes, thank you very much.
Yeah, and Novimet, so it's a private company. We are building and selling X-band radar in France, and we have installed one in Sao Paulo, and so we are specialized in the X-band radar and also on the rainfall estimation. It's the main activity of Novimet, developing software and tools to estimate accurate the rainfall from vaporization radars. At the end, I will just show you 2 or 3 slides.
But the aim of the presentation is to talk about IRSTEA activities.
Yeah, I just came like this and tried.
And I asked to Federico if it was possible that Emmanuel come with me, because I think it's interesting to know, for you to know what we did with the FCTH.
Yes. And
it was a common project. We also have other common projects in France, and other projects which are separated. So I will present what IRSTEA do in France. But maybe
if you want to introduce yourself.
Yeah.
Quickly, very quickly.
Very quickly. Conrado, can you begin?
Conrado Rudolph. I am a research hydrologist here, focused more on the inundation of floodplains. Beginning, just starting to look at more of like the impacts of flooding on.
Okay. So you are doing more hydraulic. You deal with hydraulic models.
Yes, more hydraulic.
We have also some project in Clotilde. You met Clotilde. She's dealing with the impacts.
Actually, I didn't.
Yes, you didn't. Sorry. New.
Welcome. She's working with the HEC models, HEC RTS, HEC HMS, and HEC FIA, and she's coupling them to do flood forecasting with impact analysis, real-time simulations.
So my name is Vlad Morita, and I am a research collaborator here at CEMADEM. I just finished my PhD in computer science from the University of São Paulo. And here at CEMADEM, I'm working more with understanding the decision-making process of the monitoring room, and also try to develop some spatial decision support systems for the system for flood forecasting. Not only for floods, but also I'm trying to. In the beginning it was flood, and now I'm trying to understand a bit landslides as well.
Okay, also natural disasters.
Yeah.
My name is George Sakuragi. I'm a meteorologist and work with dual polarization radar at Semade.
My name is Wagner. I work with technologies group here in Semade, and we work together. Me and Luis Bacelari has a flash flood product that we take care, and I'd like to apologize myself because I have an appointment at 12 o'clock. That's fine. He is a good worker, so apologize myself for that. Okay.
It's fine.
Hi, I'm Marcio, and I'm a researcher in hydrology. My focus on hydrological models in different size of basins. Now I'm working the Amazon basin, but I think my next focus will be the smallest, like these works, because the focus on Semade is flash floods. In my mind is this is focus of the Semade. So especially my focus is hydrological model.
Okay. Thank you. So I'm Pierre Javelle. So I'm a researcher from IRSTEA. I'm also the PhD supervisor of Angelica Caseri. I think she came here.
Yeah, she will be. We try to I don't know how to say. We try to apply a postdoc, PhD to Angelica to come here to Semade to apply something that she did in her PhD with the weather radar.
Some slides.
Some slides of Angelica. And then maybe, I don't know, in the next month or next 2 months, she will be here with us in Semade. Maybe. I don't know. I hope. Depends on FAPESP. But, yes.
And before working at IRSTEA, I was working in Paris in the flood forecasting center of Paris. So I also done, as you guys, some operational flood forecasting. So I was really interested to visit you, Luis. Thank you. That you show me the room, the operational room.
Yeah. No, after.
Maybe if it's possible later.
Yeah, later. In the afternoon, Fred will be here with us. I think that's will be more.
Thank you. So the aim this morning is, as I said, to present you the activity of my institute, not only my activities. I have some slides from my colleagues. You know Karina, you know Maria Elena Ramos. They are both Brazilian, but they are researchers from our institute. So I'm not in the same team, in the same location, but we are actually in the same big team, in the same department. So we have a lot of interaction together. For instance, Angelica had 2 supervisors, Maria Elena and me. So that's the goal from the presentation. But my own goal is to also to well understand Semade. How do you work? What's your challenge? Because I've never been here before. And of course to identify some possible collaborations. So Luis, write your name. Of course, your name. Because we began to discuss with Luis with his master, and we'd like to go further. So first, some few words about IRSTEA. So it's a French research center. So it's a public research center. We have different departments. I am from the water department, so there is 3 departments. I am from the water department. We have 9 regional centers in France. This is France. So, oh, the screen don't show all the.
Don't show all the whole slides.
Yeah,
Okay.
never mind.
No, okay. I'm going to. You can continue.
I continue with just administrative information about IRSTEA, so it's not so important. 3 centers which are dealing with hydrology. So Maria Elena and Karina are from Antony. I am from Aix-en-Provence in the south of France. And we have a 3rd center in Lyon. They are also doing some things. For instance, in Lyon, they are doing hydraulic modeling. And we have, each of us have its own, how can I say, specialization. Okay? But we are all working together. For instance, in Aix-en-Provence, we are in the south of France, where there is many flash floods, so we are more specific. We are working more on flash flood, and in Antony, Maria Elena is working more on bigger catchments with reservoirs and to try to forecast for the next few months what will happen, and me, I try to forecast in the next few minutes what will happen. But it's okay, never mind. Do it. I think it's my laptop, so never mind.
Okay.
Never mind. Yeah, you see the whole picture here, the small one. So you have 2 possibilities. Have the good one, but just half, or all the pictures, but very small. So today I want to focus on 3 examples, 3 operational examples. I think it's better to talk about concrete things, an example. The first one is, so you can see very well, the GRP model. It's what developed Karina and Maria Elena from Antony. Second example is what we do here in Aix-en-Provence, the IGA method, especially dedicated to flash floods. And the third example is what we do with Novimet. So what I call the rainpool platform, because Novimet and Stellit, this platform, connected with the X-band radar in Sao Paulo for FCTH. So first, what do Karina and Maria Elena in Antony? So they are dealing with flood forecasting for gauged station. So where you have information. So where you have water level, where you have discharge, and where you have past information.
For hourly data, we have the level.
And the discharge? Not the discharge?
Not the discharge, just a few stations.
Okay.
We have the discharge information.
Yeah. Okay.
Very, very few stations.
Yeah, that's what we saw.
Because if you are working with the daily data, we have more stations with discharge.
Okay. That's what we saw when we worked with the FCTH. They have many stations in real time, but not so many discharge information. And for us, for hydrologists, it was a big problem. When we want to calibrate a model, it just has the water level and you don't know what the discharge is. It's quite difficult. So Karina and Elena, they need discharge. And they try to forecast it. So they use different approach, different method. I will talk from that later. In the middle, you have the GRP model, but also here on the left on the hunter, they also work on, especially Mariana work on ensemble rainfall weather, ensemble weather forecast. I don't know if you also, I think, yes, here in Semaden you also use this kind of project. The main idea is to say that you have uncertainties in your forecast, and you don't know what will be exactly the exact forecast. So it's better to use not one forecast, but for instance 30 or more scenarios, and they enter all the scenarios into their model. And as a result, they have also different scenarios for this charge. And we use it for management application and to warn people before flood. So here is a focus on the GRP model. This model is used now currently every day in flood forecasting centers in France. You have in the middle, it's a map of France, and the violet, purple color represent all the. No, first the borders are here. That are the borders of the flood forecasting center in France. So you have to know that we have a central service, which is the CHAPI. So I think the CHAPI and the Semaden are exactly the same. So the CHAPI is in charge of coordinating. Now it's 29 regional flood forecasting centers, and the color indicated here which center use the GRP model. So the purple, now the majority of them are using our model. At the first it was only the center, so 10 years ago the center in Paris, because I was working into this center. And then, after me, it has nothing to do with me, but it was Karina work to connect with people with operational and to convince them to use the GRP model. Now it's the majority. You have only 3 centers, this one in the blue colors, which are not using at all the model, and this one are beginning to use the model. And on the right, the image is so beautiful, but that's the final project of the CHAPI. They produce every day, twice a day, a map, which is public, which is accessible on the internet, and you can see the colors of the rivers. And here, the green, the yellow, the orange, the red are the level of the warnings.
But the GRP is not a distributed model. How they do this? The GRP it's not a distributed model.
No, exactly. So GRP is here. It's a simple conceptual model. Yeah. So we have some reservoirs.
They do this type of map using another information.
No. They use the GRP model. No, I have to say this map is the result of a complex process, and it's a human decision. It's not automatic result of the GRP model. And GRP model is one of the tools which are used by the flood forecasting centers. So the CHAPI is in charge of collecting all this data and to produce a map. But the decision is the decision from the local flood forecasting system, from the main at work, from the forecasters. And they use a different model, and also they use a lot observation. It's mainly based on observation. So all these rivers, you can see, have a very detailed observation network with a river gauge, with a rating curve to see the discharge. And they also have information from Météo France, from the precipitation, and they also have some forecasted precipitation. And putting together all this information, they produce this map, which is called the vigilance. So, vigilance in English. It's not a warning.
Yeah, but we understand it. We understand
Be
it.
careful, it's something could happen.
Yes.
And vigilance is for a duration of 24 hours. But maybe nothing will happen. Okay. This is for GRP. This is for where you have discharge. And a point important here is to mention that GRP assimilated discharge. So they simulate in the future some forecast, but you also put to the model what is the actual current discharge, and the model knows the error is doing and is able to correct the error for the future. So it assimilated discharge. But when you don't have discharge, you have to use another method. So that's what we call in IRSTEA the IGA method. So this work is also done for the SHAPI, exactly as for the GRP model. So the SHAPI is the Semaden, French Semaden. So they are in charge of warning for a number of rivers which are here, which are gauged rivers, but now they are also in charge of warning for ungauged rivers, and it's new, and it's much more difficult because you don't have any information. Okay, that's what the map. Sorry, this is where I put this map. Again, the map where you have information. And if you have a zoom, if you look more closely to this area, you can see that many small rivers appears and can be subject to flood. And before this new service, there was no warning system. There was some warning system, but not everywhere. And every not every city. Some cities could afford to, for instance, to buy their own warning system. For instance, we had a project with Novimed here in this area, and the cities, the French Riviera, so they can afford some private warning system, but it's not the case for every municipality in France, and so that's why we developed this method, which we call the IGA method for the SHAPI. So the principle is very simple. On the other hand, you don't have a discharge, but on the other hand, you have information about rainfall everywhere in France because of Météo France radar network. So we use this rainfall, we transform it in discharge using a simple model, not the GRP model, but I could say a cousin, simple model based on the same equations. So we can calculate discharge everywhere, even at engaged catchments, and we compare this discharge with reference quantiles, regional reference quantiles. So this
meteorological model is more like a database.
Exactly. We use. Yes, the calibration is very raw, very simple, basic. But what we do is we rerun the model with all the information. We have almost 20 years of radar reanalysis provided by Météo France. So we are able to, based on these 20 years, to know what was the quantities, the flood quantities, from the model. Not the real one, but from the model. And in real time, we compare the calculation of the model with its own kernels. You do the same? No?
Yeah, we're
Yeah,
some pieces of it. Right.
And the result is a map in real time, and we are able to communicate with people and to say them, we are not able to give them the discharge. We have discharge, but we keep it for us, but we can tell them, okay, the flood which is ongoing is a very rare flood, for instance, with a region period which is more than 50 years. Or on the contrary, we can tell them, no, don't be afraid, it's normal flood. So there's no need to rush. That's the IGA method. And as I said, no, I'm going too fast. The aim of the method is to inform about region period. So my conclusion from this slide.
So you don't give them water level predictions?
No.
Right?
Currently. But of course, that's what the SHAPI is asking us now. So we are thinking to ways. So we have a PhD, so Clotilde, that you unfortunately didn't meet.
Yeah, because in Brazil, I don't know how it is in France, but in Brazil you can have like towns that get flooded and become big flood disasters with a 2-year return period.
Exactly.
And others you get.
That's the point of the ongoing PhD. What the level do you need to warn people? In some places it will be 2 years return period. In other places it will be 100 years return period. Exactly. And it's a huge challenge. Yeah. I didn't know you were involved in this topic. I didn't choose this PhD from example, but I can send you some papers. Yeah. Just to resume the IGA method, so the developments we did with this method. So we started around in the 2000 years. And as I said, the first development was made with so the Novimed, the model, we were able to couple our model with rainfall provided by Novimed and the X-band radar. It was around 2010. We also, so it was with just one radar. So for one small area in the south of France, but they could afford to have a private company to do some warnings. But we had later another project, which is the Rhythm project, which this time involved Météo France. And in this project, we also stayed on the south of France, but this time using four X-band radar. And we did not exactly the same thing, but something close. That is to say, running our model in real time using radar data. And now, that's what I wanted to say earlier. Now the method is running operationally. It's very new. It's only from March this month. It's running officially, nationally, by the SHAPI. And the new service is called VigiCru Flash. Cru is flood in French. I can give you some example, some recent example of the new service. For instance, it was last week, I think. Very recent example. We had some first warning. So that's the very first warnings, in the real warning. I mean, of course, from 2010 we have experienced it many floods, and we are doing some reports, and we are always comparing the results and what happened. But these are the first official warning by the service. So I had a look. It was the last weekend, and you can see all look the service. It's a website. It's only for municipality, for the mayor, for the people. It's not public. It's not a public internet site.
Mm-hmm.
He will receive by SMS, email, a link, HTTP link, and he has to click and he go to this screen. So here you can see that you have the time, at what time, how many municipality was warned. So, for instance, here at 8:30, there was 6 municipality warned. So I've just made the zoom. So you have the old French map, and here I just made the zoom on 2 of this municipality. Actually, it wasn't 2. You can just see 2 names here. But if you zoom, so this is first. This was the event. It was not a so big event. And actually, there was no damages at all. But it was interesting to check that the warning was correctly sent to the mayor, but the event wasn't so bad. So you can zoom, as I told you. So I zoom on the area you just saw area. And that did the situation at 4:30, so there was absolutely no warning, and that the situation at 4:45, 5, you have the first warning. So yeah, there is 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's what you have here, a 9. You can see it's the 9 number. So 9 municipalities which are warned with the first warning level. And if you continue, I can't give you the slides because the picture's not good. If you continue, you have 1, 2, 3, 4, 5 municipalities which are warned again, but for the second warning level. And 15 minutes later, in this area, all the municipality were warning, so it means they received the SMS. And our job stopped here. After that's the municipality which have to take measure on operational measure. So it's the same thing for another area. Well, I just wanted to show you first example, not the first, but one example of what we do in real time, which is operationally. I don't know what to do here, but I think you have the same idea, the same challenge.
This system is the official system used in France.
Yes.
And the IFAS is not used in France.
Yes, IFAS is using in France. IFAS is a European warning system. IFAS is dedicated to bigger catchment, and in particular to trans-border catchment. So the Chappie received IFAS warning. Now they are running our model. They also received warning, not warning, but yes, warning, hydrological forecast from Météo France. They have many sources of information. Yeah.
So
and
you receive the information from IFAS.
Of course. And IFAS is daily. It's calculated with daily time state. So it will give you a forecast for the next week, but not for the next hour.
Oh,
for flash flood?
They have some products about flash floods.
Yes. This is another thing. For flash flood, they have a product. Now it's Eric.
Not that Eric. Eric and the Epic and Eric.
Yeah. But Eric replaced Epic.
But I saw that they use some forecast for 48 hours.
Yeah. So Eric,
24 hours.
yes, Eric and Epic as are based only on rainfall.
But it's at the continental scale, so you don't
No,
get
because-
you don't get radar data going into.
Yeah, but it's only based on rainfall, and it's only based on. It's very important. It's only based on numerical weather forecast.
Right.
So there is no radar, no
in
rain
Eric,
gauge.
you don't have those more detailed local
Yeah.
data, right?
There is no radar, no rain gauge in EFAS. Only numerical model from the European Central.
How about Eric?
Reading.
Eric, do they have radar data going into Eric? No,
No.
just the forecast.
Yeah. In a way, they have some this data because I don't know who works the numerical weather model. I think he assimilates some observation. I think I assume, but I'm not meteorologist. I think there was some meteorologist. Yeah. And it is a model from ECW, the European model.
I know that they use 128 members of forecast for
Yeah.
rainfall, and they use all discharge gauges Sweden or Europe
Yeah.
to simulate with the Discord model.
I'm not sure they are simulated.
I'm pretty sure because
You are sure?
Jutta, do you know Jutta?
Yes.
Jutta, she's
Okay. Yes, I know.
and
Yeah,
use
but
the real time.
Okay, so you know better than me. Yeah, you're probably right. Okay.
what I think they don't do yet is reservoir operation.
Yeah.
I don't think they do that.
But I'm really not sure they assimilate in real time. But maybe on a research.
You can access the system and see some real time stations. You can see the values.
Okay.
On the system.
So it's maybe new. But when I was in Paris or the operational center, I knew
But
that.
just maybe more information for your system. You can get this.
Yeah, and it's maybe new because I'm quite sure that 5 years ago but it's another good point. It's a good challenge for this kind of method to be able to assimilate the discharge. And from our method IGA, we don't do it now. And it's another project to be able to assimilate discharge because the models are imperfect and the base information is the information you measure from the field. So if you are able to collect it in real time, it's not so easy. And then to assimilate it into the model, it's very valuable. Yeah, if you have some questions.
Sorry.
Yeah, thank you for coming.
Could you please
Send the presentation.
yeah. And basic question. GRP stands for? GRP
GRP is
stands for?
stand.
What does it mean?
Ah.
Stands for?
Yes, French is génie rural. Rural genius. I can't translate. But it's the old name of our institute. It's come from the old name of our institute, which was CMAGREF. GR is for génie rural. I can't translate in English. So. We asked to Karina or Maria Elena. She will translate you in Portuguese. Thank you. Yes, if you have another question on IGA, also on GRP, but I'm not the expert in GRP. Karina is the expert, and Elena. And the next subject slides is to talk about Angelica. Do we move to Angelica?
Yeah.
So she defended her PhD this month. So it's very new. So March was very positive month for us because this new service was put in operational. Angelica defended his PhD. We had this travel in Brazil. So it's quite crazy, but it's nice. So what did Angelica? Do you have some information about this work? Did she already present to you the work? I know she already came. Yeah.
No, I did.
I know that you
last year I did a presentation of some parts of my research in the debate series, and I just talk a little bit about Angelica work using the first paper that she did with.
But you already presented some.
Yes, with just some colleagues.
Yeah. Okay. So I've just 3 slides, so it's very short. And the aim of Angelica is to produce a rainfall forecast because, as I said, in our method, the AIGA method, currently is very basic. It's just what I've presented. We just compare calculated discharge with past calculated discharge, just to get the return period. We don't assimilate the discharge. We don't have a water level, so we don't know what will be the area flooded. So we want to do that. We want also to know the area flooded. And the other thing we don't do is to take into account rainfall forecast. We only use observed rainfall. So that was so we have different PhD students in our team, and each subject is the PhD actually. And Angelica was dealing with the rainfall forecast. And Maria Elena was also the supervisor because, as I said in the introduction, Maria Elena is an expert in ensemble forecasting. So we wanted to introduce in AIGA some uncertainties. And I think that you need to do that because nobody can be sure of his forecast, especially in operational systems where the uncertainties are everywhere. So you need to be aware, not to cache
Disregard.
Huh?
Hide.
Yes, thank you. Not to hide the result, but on the contrary, to show this is my results and this is uncertainty. That's an information. And on this animation, you can see what Angelica did. So on the left is the radar information. And then they simulate different numbers. So that's the same information, but associated with an uncertainty. And then she put this forecast into our model, into the IRSTEA model. She used what we call a simulation, conditional simulation. So what is it? What's the idea? The idea is to say, in some point, you are more confident with your data, and in other point, you are not confident at all. So when she generated all these numbers, she is able to point some points and to say, here I'm sure. So I want that all my number have this value. So here is an example with one conditioning point, and another example with 2 conditioning points. And here is the space in 2D, and here is the amount of rainfall. And that's what we want to do with Louis. So
yeah. Just to summarize very quickly, it's just a statistical method. They try to combine the weather radar structure of the rainfall with the values of the rainfall in the rain gauges. So they try to make ensembles to show the uncertainties of the rainfall combining the weather radar and the rain gauges. And then they apply this to the IGA.
I didn't say we did with the rain gauge.
Okay.
But we did with rain gauge. But that's a discussion we began with you.
Yes, because you can also
apply the method. Because we were not so confident with the radar, we wanted to say that the rain gauge were more precise. But we can't say that. Maybe it's the rain gauge who are wrong and the radar is correct. So we did that for the PhD, but you can use the method with another perspective. For instance, we are talking to the car.
I cut my car from school, so
okay.
No problem. I also have some children. It's too far to fix them up.
Yeah, they
and it's an interesting point to discuss about with you. We had this discussion with Emmanuel. He told me, why don't use radar images? And I remember when we talked together, you told me
yes.
You want to use the forecast.
Yes.
And you want to.
Yes. What I'm trying to do is to make an ensemble using this method of the TBM, but with weather radar extrapolation with the images that we have already in the nowcasting. So in this work with Angelica, she tried to extrapolate the precipitation to go further, but just using the last images, because they have an advection, but the advection is just in one direction. In the extrapolate method that we have in the
How do you work your extrapolating method? You don't have only one direction.
You can have different directions, depends on the size of the convective storms. They can go to one point, and the other convective storm they can go to another.
It means that you identify the cells.
Yeah, identify the cells.
For each cell
yes.
Okay.
Yeah.
Yes, it's really good to test and to compare, because we don't.
I can show after in the afternoon. I can show you the other images that I did.
And you do the tracking.
The tracking.
But you do, or
no? They do. They do with the software of the weather radar. They do the tracking from the Selects. They do the yes. The method of the tracking from Selects is the
by cross correlation.
Cross correlation, but how do they identify the cells? Because we do cross correlation, but for the whole picture.
That's I have the name and the method.
To define different
yes. The name of the method is Titan. I think that.
Yeah.
Titan.
We are interested. If you have some, you know. Because what I didn't say, but you will say it later. The Novimet also developed a method for tracking.
For tracking. Yeah.
And we would like to improve it.
Yeah, we use like cross correlation between two or three less images.
Yes, but when you do that, you do that for the whole picture.
Threshold like 35 dBz, for example.
Yeah, we use threshold. Yeah.
Polygon. So you apply correlation. Establish vector.
Vector match.
Yeah. So in this case, you really can have like a vector that we have 10 or 20.
Yeah, just
or even every 1 kilometer if you can extrapolate. But we are not using selling, because there's like two methods. You have like cross correlation techniques and also selling tracking, cell tracking.
It's possible.
Yeah. So you use both methods, or you
rain just cross correlation.
Okay, that could be a subject.
Just if I understood, you would like to apply this TBM approach, but not on the rain observation, but on the rain forecast.
Yes.
So you will get like 20 numbers at each.
Yes, you use as for example, I want to do a forecast for the next 2 hours.
Yeah.
So I have the nowcasting of the weather radar, and then I'll use this nowcasting as the condition of the points that I'm using in the image to generate the ensembles with these points that I'm using as the prediction. So I will. Okay, you can move forward.
It's an idea.
You can continue.
So that was for Angelica.
Yes.
I didn't say too much.
Okay.
I think you already said much more, given equations and turning one. And
Okay.
I always do simple things.
Okay.
But I think it's the main idea you have to keep in mind. And the last example I want to talk is what we did with Novimet. And as I said, we have a first experience in France, and now we have a second experience in Sao Paulo together. And that was made in the framework of a FACEP project. So not FAPESP, nothing to do. FACEP is it means that it's a French project which is funded by the French government.
Yeah, participation of the French government in the.
Yeah, the aim is to promote private French company and to help them to export their product all over the world. And